So for today, we are starting chapter 6. I'm going to be honest with you, of all the chapters I teach you, this is my least favorite. Sorry. I'll just be honest, it's my least favorite chapter. Some students get it right away. It's radicals. And if you think back to when we did a lot of radical stuff before, some of you struggled, some of you did great with it. So it just kind of depends. We'll see how it goes. Yes, nth. Nth just means to any. Yeah, it's just like a generalization. So we're going to do section 6.1. If you notice your packet, if you actually flip through there, you have 6.1 and you have it switches into 6.2. So we're going to do all of 6.1, which is pretty quick, short, simple, and then I'm going to do like part of 6.2. Okay? Tomorrow, it's going to be just work time. You guys are going to be exhausted after all day of Explore Pen and whatnot. So if you're not here, you're not going to miss new material. And of those of you on work placement, those of you that are here, if you don't get a chance to finish your homework in class today, just save it and you can finish it in class tomorrow. Okay. I don't have my other algebra class. So it's like, I'm not going to move on with you guys and not move on with that. Like, no. So tomorrow will just be like a work day, finish homework if you don't finish it today, like something like that. Sound good? Maybe I'll put on a movie. I don't know. We got 50 minutes. What's up, Doug? So yours, it'll be due on, it'll be due Thursday. So just make sure it's done Thursday. Yeah, today's Tuesday. All right, so here we go, guys. 6.1 is evaluating the nth root. It sounds really hard, but it's not that bad. So the nth root of a. So every radical we've done to this point has been a square root. Right? We did a little bit of cubed roots, and we did the sum and difference of cubes for factoring, but nothing major. So we're looking at, if I ask for like the fourth root of something, I'm referring to that little number right there. Is that little number the radicand or the index? The little n. Which one is that? It's the index. The one under the radical is the radicand. The index is that little bitty number. That's whatever the root is. Square root, cubed root, fourth root, fifth root, sixth root. We're going to have all of those. Okay? All right, so grab your calculators. Let's get used to some buttons on that thing. Because let's be honest, most of these numbers you probably won't recognize like you do square roots, right? Square roots are kind of second nature. We're used to dealing with those. If you're dealing with the other ones, we need to figure out where those buttons are on your calculator. So if you are using a graphing one, if you look underneath math, which is underneath your green button, you have option number 4 is your cubed root. So like the number 1, if I want to do the cubed root of negative 216, I would hit option 4, which would bring up the cubed root. And then I could type in negative 216. You should not get an error. It is negative 6. So if you were on the graphing calculator, hit the math button. It's right underneath the green one. And it would be option 4. Okay. If you're on a scientific calculator, can I steal yours for a minute? So I can reference your buttons. Scientific one, you would have to hit the 3 first because you wanted the cubed root. And then you would hit second. And then you would hit the caret button. And then type in negative 216. It usually opens a parenthesis up when you do it. Did it work that time? Okay. Okay. Anyone not able to figure that part out in the calculator? Okay. So number 2 wants the fourth root of 81. Okay. So on the calculator, scientific is going to be the same idea, except you're going to hit a 4 first because you want a fourth root. If you're on the graphing one, if you hit them, you're going to have to hit 4 and then the math button and then option 5. So you'd hit 4, math, and then choose option 5. And it should pop up with the fourth root little symbol, and then you could type in 81. And what do we get? Just 3. Now, I know these are nice and pretty and perfect, and we're going to look at some perfect ones. But I want you to kind of stop for a minute and let's think about what this means. Because they're not all going to be perfect. Right? When we did square roots, how did we simplify square roots that weren't pretty and perfect? What did we have to do? We did trees. So let's look at the tree on this. I want you to kind of see what's happening here. If I do a factor tree on 81, we know that's 9 and 9, and then 3 and 3, and 3 and 3. Now with square roots, we looked for pairs. Why did we look for pairs? It was the square root. If I'm looking for the fourth root, I need groups of 4. See how there's 4 3s? So one group of them comes out then, and it's just 3. Yes. So if you didn't have a calculator, can you do a tree? Yeah, you sure can. So, yes. So like down here, the 6th root of 64. So if you would do that, you're like, okay, that's 8 and 8, 4 and 2, 2 and 2, 4 and 2, 2 and 2. It's a lot of 2s. But how many would you need to be in a group? You need 6 of them. 1, 2, 3, 4, 5, 6. I had 6 2s. What? I don't know. Hopefully you're okay. You all right? I heard that. All right, so what's the 4th root of 625? And again, if it's perfect, by all means, use the calculator, okay? Type it in, get the perfect answer. Cubed root of 64 is 4.
I'm sorry, I'm not reading.
She's typing them in the calculator.
Oh.
But hold on, let's take a look at this one. If I did this one, 8 and 8, I know I got it over there, but let's look at it again. Bless you. So if I look at it this way, I need how many in a group? I need 3. So 1, 2, 3. So there's 1, 2. And then 1, 2, 3, there's another 2. 2 times 2 is 4.
Oh, wow.
So just really the same way we did factor trees and whatnot for regular square roots, but now I just have to look for different numbers in the group.
Is this really?
It's the initial idea. Bless you. If you're understanding this today, then we should be good with today. What's the 5th root of 243? Is 3. No. All right, but honestly, guys, personally, if I'm like looking at numbers and I'm not sure if they're perfect or not, I'm going to type them in my calculator first, and if they're perfect, great, then it saves me a lot of time, right? Because some of these factor trees get a little big. The calculator, if they're perfect, will always give you the perfect answer. If they're not perfect, you have to do the factor tree because it'll give you a decimal. And we don't want decimals. We want exact answers. All right. But you know, we don't always just do numbers. We have variables. Welcome to algebra, right? So the square root of x squared, it's just x. But what about the square root of x to the 4th? It would be x squared. Let's see how far you guys get with this. The square root of x to the 6th? What about the cubed root of x cubed? Just be x. Cubed root of x to the 6th? I'll explain if some of you are like, how are they doing this? That would be x to the 5th. What are they doing? It's your exponent divided by your index. That's the shortcut. But I want you, again, I want you to be able to reason through this. Because are they always going to divide perfect? No, they're not. So think about, what does x to the 6th mean? It means I have 6 x's. It's obnoxious to write them out, but that's what it means, right? How many do I need to be in a group? 3. So if I put these 3 in a group, that comes out as one of them. Here's another group. How many groups did you have? Excellent. It's not always going to be perfect. So and again, if I had 10 x's, I hope after how this works, so you can write it all out. I want you to see it. I need 5 in a group. So like 1, 2, 3, 4, 5. There's one group. 1, 2, 3, 4, 5. There's another group, and there's none left over. So they all go nice and pretty. There's 2 groups. Well, yeah, because they're not always pretty and perfect. I mean, I'm going to get you there eventually. Let's go nice and slow. You know me, I baby step you. So 14, the square root of 16x to the 8th. What's the index? What's the index? 2. Oh my gosh, we've had unspoken 1s. Now we got an unspoken 2. It's a square root, so the index is 2. So what's the square root of 16? And the square root of x to the 8th is x to the 4th. Remember, you can just take the exponent and divide it. So 8 divided by 2 is 4. Cubed root of a to the 6th, b to the 9th. Yeah, what's 6 divided by 3? 9 divided by 3? Yeah, if there's no index, it means it's a 2. I say unspoken 2 now. Now, guys, I'm going to caution you on mistakes I see happen all the time. Is a lot of times people write their index number, that little number, they write it real big. If I write it real big, what do I assume it is? A number out in front that's being multiplied. Or I have students who write their answers when they're not nice and pretty, and they have like an actual radical still on it, they don't write the index down. If you don't write it down, I assume it's a 2. And if it was supposed to be a 3, it's wrong. Okay? So just be careful. How about the 4th root of x to the 8th? And y cubed. Again, if they're pretty and perfect, I'm just doing 8 divided by 4, 12 divided by 4. I can just divide them. But you know me. They're not always perfect, right? Of course it will. But is it harder yet? Square root of 81? Square root of x to the 4th? Oh, that one was all right. You guys notice I'm kind of doing these one piece at a time, right? I can do them one piece at a time. Cubed root of 27? Cubed root of a to the 12? For anyone not sure what these numbers are called? Cubed root of 27. Yeah, you can put that in your calculator. Yeah, for the numbers, you can just type the numbers right in there. Yeah, we're not doing squares. Yeah, we're doing cubes. I know you don't always recognize those as much. And 4th root of x to the 12th? And y to the 4th. You could just in your calculator type in the cubed root of 27. Or you could do a factor tree on it if you don't like the buttons on the calculator. Got it? In this chapter, yes. But we'll save those for Thursday. You'll be back Thursday. You'll be here. All right, number 20. Now's where it gets real, guys. Square root of 48? Oh, ooh, that's ugly, right? Terrible. So what did we do before? If it wasn't perfect, we do a factor tree. Yep, it always comes back. Look at that. Math comes right back again, guys. We haven't done these in how long? It's been a long time.
It took me like a week when I first learned it.
Oh, stop it. Would you be here already?
No, I was
What's the index? So I'm looking for groups of 2. So I have a pair of 2s. I got another pair of 2s. And what do I do with that single 3? It goes back under the radical. Notice I left a space for a reason, because I have variables up there. Now, x cubed means I have 3 x's. So how many are in a group? 2. So if these two are in a group, that means there's one that comes out, right? And then what do I do with the one left over?
Put it
Under the radical. And then my y's, I have 2 groups of 2. So y squared. Any underneath? No. And I can just clean this up. I had 2 times 2 sitting there. So 4xy squared, radical 3x. I'll tell you right now, I hate grading these tests. Look how tedious they are to grade. Every little exponent, every little index, like, yuck. Yep. They're the ones without dates, right? They got to stay in and watch Netflix. Yeah. Mhm. We're not on that one yet. Good question. We had a problem earlier where there was a negative under the radical and we did not take out an I. It's because it's not imaginary. Let me tell you. No, we're not graphing. On 21, take a look at this. The negative under the radical, you guys have been programmed, negative underneath, pull out the I. I've been programmed you that way, right? I mean, seriously, that's your first instinct to pull out the I. It's what you always do. That index is a 3. Think about that. What do you multiply to get a negative 27? 3 times. Negative 3 times negative 3 times negative 3 is what? 3 negatives make a negative. So can you do negatives under radicals? Yes, but what must your index be? Your index. It has to be an odd number. Yeah. If your index is odd, then you can do negatives. If your index is even, you pull the I out. Yep. Let me write. I'll jot it down for you down here. If index is odd, no I. We'll just write no I. Because it can work. Because you can have an odd number of negatives will equal a negative. It works out. So if index is even, pull out an I. And again, I'm only talking if that's negative underneath there. So if your index is odd, there's no I involved, okay? You can just do the problem. And again, if you type it in your calculator, it'll give you the answer. It's negative. Dakota? We had 2 groups of 2. Mm-hmm. That goes way back to the beginning of the semester because it was a square root. Yes. Mm-hmm. Okay, so let's come back to 21. My index is odd, so there's no I. It's okay. What's the cubed root of negative 27? Is that pretty? Negative 3? And then what's the cubed root of x to the 6th? That's x squared. So is there anything left over? No, there's nothing left. If I did a factor tree, I'd have all my 3's would be accounted for. If I did with my x's, I'd have perfect groups. There's nothing left. Adrian? Number 22. 5th root of 128. Is that perfect? Type it in. No, it's not? All right, well, if it's not perfect, always try first, because my gosh, it's way easier if it's perfect. Good. 2 and 64. Very nice. Let me re-explain what he just said, but that was perfect. That was perfect, Christian. So how many do I need in a group? I need 5. So 1, 2, 3, 4, 5. So that means one group comes out, right? Because I had to have 5 of them to group together to come outside. How many you got left over? So 2 times 2 is 4. So that's going to go back underneath here as a 4. Now, don't forget that little index of 5. If you don't write that little bitty 5 in there, then it's a square root and it's wrong. I know, people forget it all the time. All right, so that was us dealing with the 128. Questions there? Okay. What about from the x's? Can I take a group of 5 from there? No, I only have 2 of them. I don't have 5. So they stay underneath. I don't get to pull any out. It's my index. Yeah, whatever the index is, that stays. And then how many groups of 5 can you take from there? 5. So that's y to the 5th. Mm-hmm. So the 128, I did my factor tree. We're okay with that? And then since it was a 5 for an index, I need 5 of them to come outside. So I cross off 1, 2, 3, 4, 5. So there were 2, so a 2 came out. And then I still had this one and this one left over. So to put them back under, we always multiply them back underneath. Mm-hmm. Other questions before we move on? 23. Cubed root of 135 x to the 5th. Cubed root of 135, is it perfect? No. So if it's not perfect, factor tree. What it? 15 and 9. I'd have went with 5 and whatever he just said back there. But it's okay. There you go. That's where I would have went. Because it's something I can think of in my head that I know 5 goes in there. 3 and 3. All right, so we do our factor tree. I need 3 in a group. So what comes outside? A 3. A 3. All right, what stays underneath? The 5 stays underneath. Don't forget your little index. Can I take a group of 3 from here? Yeah, and again, think about if I have 5 of them, I need 3 of them, so these can come outside. I'd have 2 of them left over to go inside. Yes. A point off every time you forget it. Yeah, it's kind of like that plus minus you guys would forget, things like that. Yeah. Yeah. Baby brother. All right. I love how she was explaining that. Remember baby brother? Hey, whatever helps you remember, right? All right, 24, square root of 80. That's not perfect. All right, so what's factor tree? Good. Now, on number 24, what's the index? Because there isn't one. It's a 2. If it helps you to get in the habit of always writing an index, you can write the 2s. Just like I don't count off if you write a 1 in front of an x, right? Like it's okay. So I have a group of 2 there and another group of 2. So that would be 4. 2 times 2 is 4. Good. The 5 goes back underneath the radical. And again, if you want to write the little 2 in there, if it makes you feel better, so you get in that habit of always writing them. All right, now my x's, I want groups of 2. So there's 1 group, 2 groups, 3 groups. So x to the 3rd, because I have 3 groups. What goes back under? Just an x, because there was one little guy left over. And then the y's, it's y cubed. And there's no y's left over. Can you pull that shut? Thank you. I had 3 groups and there was one little guy left over. because I was taking groups of two, group of two, group of two, group of two. He's by himself. So he has to stay inside and watch Netflix. I love all the helping teaching going on. Like, it's fantastic. Is there other questions you guys have for me before we move on to the next one? All right, so 25, I have a negative underneath. Is that okay? Yes, because it's an odd index. So it's okay. If it's even, you have to pull an eye out. Yeah, but since it's an odd index, it can be negative. That's okay. So fifth root of negative 96, is it perfect? It's a decimal. Okay, so that means we have to do a factor tree. Now, I'm going to be honest with you guys. Right now, at this point, that negative, I'm going to ignore it, but just remember it down at the bottom when I write down my answer. Okay? Because you know your answer is going to be negative, right? It's going to take you 5 negatives to get a negative. Like, it's going to happen. All right. So 3 and 32? 2 and 16? 4 and 4. I don't care which way you guys go. It's just, I don't have a calculator in front of me, so I have to do what I can do mentally the easiest. Good. All right. So how many do I need in a group? I need 5, because my index is 5. So 1, 2, 3, 4, 5. So what comes out here? A 2. What goes back under? I have a 3. Now, what did I lose already? The negative. That's a negative 2. Because the original problem was a negative 96, it's going to be a negative that comes out. Since this was negative, that way I still keep that negative. It's okay. All right. How about the A's? Hold on, what extra 2? I needed a group of 5. There's 1, 2, 3, 4, 5. So it's just, there was one group that came out. The extra is the 3 at the top, so he went back under. Right. 5 is the number that has to be in the group. All right, so then let's stop for a minute and look at these A's. I have 6 A's. I need 5 in a group. So I have 1 group that comes out, and I have 1 lonely A that's left over. 1 group of 5 comes out, so just 1 A comes out, and 1 A has to stay in. How about the B's? It's going to be B squared, and what goes in here? Another B squared. Again, if you're not certain, whew, a lot of B's. I need a group of 5, right? So there's 1 group of 5, another group of 5, and there's 2 left over. So 2 groups come out, 2 are left over. It helps you to see that visually, write it out. It's okay. All those B's? Yes. Because you have the crazy calculator that does it for you, don't you? I may make you switch calculators when it comes time for the test, because I need to make sure you know how to do it, not just your calculator. Either that or show me your factor trees. He's right there. I have my my screen set wider so it fills my screen without the bars on the side. I could. Okay. So that is the end of that section. So we're also going to look at part of 6-2. So we just did simplifying a single, right? If you think back to when we did square roots, we started the same way. We started with a single one, then we moved into multiplying, then we moved into dividing, and that became rationalizing and all of that good stuff. So we're going to look at, we did simplifying, we're going to do just multiplying today. Thursday, we'll do dividing and rationalizing. because that gets a little trickier. Okay, so we'll just look at multiplying. I may not even do all the examples because I think we'll be okay. All right. So for multiplying, if I have radical 27 times radical 3, radical 81. Okay. So just like before, we always multiplied them together first, right? And then we simplify. What's this? That's just 9. Yes. So number 2, the cubed root of 9 times the cubed root of 81, which is? And is that perfect? It would be an ugly mess. That is just 9. Fourth root of 8 times the fourth root of 32. And that is just 4. Square root of 6 times the cubed root of 12. I look like, can you do that? They're not the same. I can't multiply them. Notice these are fourth roots, those are square roots, those are cubed roots. They matched. If they match, you can multiply and put them together. If they don't match, I can't do anything with that. Okay? Questions? That's it. I can't do anything. Beautiful. There it is. Simplified. I can't do anything with that. Nope, you can't. I mean, you could see if like one of the numbers inside of there matches up, like simplifies. But like if I do a factor tree here, I get 2 and 3. I don't have a pair of anything. 2 and 6, 2 and 3. I don't get 3 of anything there. Nothing simplifies. I might, just for giggles. But they're easy. Like they don't match. I'm done. They don't match. All right. So 4th root of 7x to the 6 times the 4th root of 32x squared. So we multiply first. They're both 4th roots, so that stays. What's 7 times 32? And that would give me x to the 8th. Remember, when you multiply, you add exponents. So multiply them first, and then let's try to simplify. 4th root of 224, perfect? Okay. If it's not perfect, we do our tree. Well, I know that's 7 and 32. That's where it came from. Then that's what? 6 times. My brain stopped functioning for a minute. 6 doesn't go into that. 8 and 4. Whew. A week off's too much time, you guys. 4 and 2. 2 and 2. Another 2 and 2. All right. How many do I need to come outside? I need 4 because my index is 4. So 1, 2, 3, 4. I have 4 2's, so a 2 comes outside. What stays under? I have a 7 and a 2, so that's 14. Don't forget your little index of a 4. Or I take a point off every time it's missing. And then what about my x's? That's just x squared. 8 divided by 4, that's just x squared. My biggest suggestion to you guys on these is make sure you kind of space things out. Otherwise, you get all crammed inside of there, and it's hard to read and hard to notice your exponents from your index and everything else. All right, number 6. Ooh, there's big numbers out front. What do I do with those? You multiply them. Yeah, you have a 2 and a 3, which is 6. What is 6 times 9? I'd have x to the and y to the 3rd. Remember, there's a 1 there. Okay, step 1, just multiply them together. Outside numbers multiply. Inside, as long as the radicals are the same, they multiply together as well. Add exponents. Okay? Cubed root of 54? Not perfect, so we'll do our factor tree. So we do our factor tree. How many do I need in a group? I need 3. So I have a group of 3 3s. So that means if 3 comes outside, and it's going to multiply by the 6, we're going to have 18. I want to make sure everybody saw what I just did. We had a group of 3s. They came outside, but they multiplied by the 6 that was already there. 3 times 6 is 18. All right. How about, could there be x cubed and a y? So what's underneath here? Anything? There is a 2. All right. So we did our factor tree on the 54. We had 3 3s, so they came out, multiplied by the 6 that was already there. I got 18. I need groups of 3 from the x's. So then I had 9 divided by 3 is 3. It's perfect. 3 divided by 3 is perfect. So one of them came out. If you want a 1 here, if that makes you feel better, you put the 1 there. And then in my factor tree, the only thing left over was that 2. So he went back underneath the cubed root. You had x to the 4th and x to the 5th. We add exponents when you multiply. Other questions? This 2 inside here, he was the leftover piece from my factor tree. He didn't have a group. Yes. Where did I get the 18? I had a group of 3s that came out and multiplied by the 6 that was already out there. This 6 came from multiplying 2 times 3. So he was already out there. And then I had a group of 3s that came out and they multiplied by him as well. You're welcome. Other questions? We doing okay? Awesome. Let's skip 7 and 8. Not my problem. You work ahead. Let's jump to 9 and 10. Yeah. Thursday, we're going to do dividing and rationalizing. Okay. All right, so number 9, they're both 4th roots, so I can put them together. So what number is on the outside? -2. And then we're going to multiply these together. So I have 9 times 18, 162. My x's is going to be x to the, and my y's, stop me at any step where I lose you, okay? All right, so I just multiplied. That's my first step. Now let's try to simplify. No, it's not perfect? All right, so that means we got to do our factor tree on the 162. Yeah. So 9 and 18. 3 and 3. 9 and 2. 3 and 3. How many do I need in a group? I need 4. So I do have 4 3s. Good, so I'm going to have a -6 out in front. Stop me if I just lost you. Had a group of 3s. It came out, multiplied by the -2 that was already there, so it gave me -6. Group of 3s times -2, -6. All right, leftover, that little 2. So he goes back underneath here. All right, and then let's move on to our variables. So I have x to the 9th. So it's going to be x squared out here. How many is left over? And again, I know some people struggle with that. That means I have 9 of them. I know it's obnoxious to write out, but it's nice to see things visually. Groups of 4. So a group of 4, group of 4. So I have 2 groups that came out, x squared. And there was 1 guy left over. He stayed inside. Good. And then this 12 divided by 4 is just 3, so y cubed. Again, if you wrote out all your y's, you'd have them all perfectly in groups. Nobody be left over. So nobody goes inside here. And we're done. Yay. 10 on your own. All right, guys. Let's finish up the last one for today. Yeah, last one for the day. Yep. Yep, and I'll give you the rest of the time to work. And then you'll have tomorrow afternoon to work, too. Yeah. Nope, all of what we did today is homework. All right, so number 10. First thing, let's multiply the outside number. 6 times 3? 18. Then we're going to have a 5th root, 10 times 160, 1600. Then we're going to have x to the 7th y to the 6th, z to the 5th. Two things at this point. Double check that you have all of that exactly the same as me. And if not, fix it. And then make sure your radical actually covers all of it. Remember, we've talked about that. If your radical's not long enough, then it's considered incorrect. I will take points off. Yep. All right. From here, that is not perfect. Doesn't matter. We end up same spot. Don't matter. All right, how many did you need in a group? Hey guys, we're all talking right now, but we don't know that your answer is right or not, so pay attention. All right, we need 5 in a group. So 1, 2, 3, 4, 5. Don't matter, whatever number you have 5 of, whatever. In this case, it was a 2. Times the 18 is 36. Some of you panicked because there was a lot of leftovers. That's okay. It's 50. So the 5th root, 50. Make sure you have your little index 5 in there. 5 times 5 times 2 is 50. Yeah. All the leftover pieces that you have, they get multiplied back underneath. They're all leftovers. What's really wrong? You were factor tree? Did you say 10 was 5 and 5 instead of 2 and 5? You should still end up with the same numbers. I'll look at yours in a minute. All right, guys. From there, let's take a look at your variables. I need a group of 5 from the x's. How many groups of 5 can I get out of that? 1 group of 5. How many would be left over? There'd be 2 left over. How many groups of 5 from the y's? How many is left over? Groups of 5 from the z's? Left over? None. So does 36x, y, z times the 5th root of 50x squared y. Be thick. I do want to, again, draw your attention to, I will have to grade these. I need you to look at all the little numbers in there. Please write legibly. It's going to come down to if I can't read it, it's wrong. It's kind of a wrap. So just keep that in mind. When you have exponents and index numbers and all these pieces, if I can't read it, it's just wrong.
I knew I'd